reteach paper 9.4, there are 4 problems. And I turned each of those problems into a word problem to help you understand how the least common multiple can help you solve word problems. So the first one that I did, on your reteach paper, the problem was 10 and 15. And this is the word problem I created. Every 10th day of school, the 5th grade class has ice cream for a snack. The 4th grade has ice cream every 15th day of school. If both 4th and 5th grades have ice cream today, when will be the next time they have ice cream for snack on the same day? There are 2 ways to solve this. Way 1 would be to list the multiples of each of these numbers. So the multiples of 10 would be 10, 20, 30, 40, and the multiples of 15 would be 15, 30, 45. And already you can see that what they have in common is a 30. So, both the 4th and 5th grades, they will have ice cream again for snack in 30 days. The second way to solve this would be to do it using prime factorization. So, let's see, I need to create some space here. Well, let's see how we do it here. We have 10. And we're going to find the prime factors, which would be 2 times 5. We have 15, finding the factors. Prime factors would be 3 times 5. Now what I'm going to do is list them as such. 10 would be 2 times 5, and the multiples of 15 would be 3 times 5. What I'm going to do is use the 5, so I'm going to group those together, and I'm only going to use these numbers once. So now what I'm going to do is I'm going to multiply my other factors, 2 times 3 times 5. I'm only using them once. When we had done this for greatest common factor, we multiplied each of them, but in this case, you're only using them once. So now I'm going to multiply 2 times 3, which is 6, and 6 times 5 is 30. So again, we come up with the same answer, that in 30 days, both the 4th grades and the 5th grades will have ice cream on the same day. Let's take a look at problem 2. On your reteach paper, the original from the book, the numbers that they give you are 12 and 21, and they want you to find the least common multiple. So what does that mean? Well, we're going to look at the word problem I created. Mrs. K is going to the Flyers game tonight. They will be handing out bandanas and clappers to the fans. I love free stuff. They hand out bandanas every 12 games and clappers every 21 games. And how many games will both bandanas and clappers be handed out at the same time again? Well, the 2 ways we can do it. One, we have 12 games, so every 12 games they will hand out bandanas, and then every 21 games they're going to hand out clappers. So let's see what we have here. So 12, I'm going to write down the multiples, 24, 36, 48, and I'm going to do 21, 42, 84, nothing in common yet, so I think I'm going to have to keep going with my 12. So let's see, we have 48, 60, 72, 84, 96. Okay, let me go back down to the 21. We have 21, 42, 84. And look at, we have 84 in common. So every 84 games, they will hand out bandanas and clappers. Now the second way we can do it is using prime factorization. So I'm going to take a look at the 12, and let's factor that. So that would be 3 times 4. I can factor the 4 again, 2 times 2. So I have 12, and my factors are 3 times 2 times 2, and my other number is 21. And if I factor that out, it would be 3 times 7. So now they're prime numbers. So let's take a look at 21 here. So 3 times 7. Notice that we have the 3's in common. I'm only going to use one of those. I'm going to use it just once when I multiply. So I'm writing down use once. And so now when I multiply, I'm going to say 3, because I'm using them once, times 2 times 2 times 7. 3 times 2 is 6. 6 times 2 is 12, and then 12 times 7 is 84. So again, I come up with every 84 games. They will hand out both bandanas and clappers together. So let's take a look at problem number 3 now. Today is your lucky day. You will earn a yellow probability ticket and a blue probability ticket. I will hand out a yellow probability ticket every 9 days and a blue one every 15 days. When will be the next time you can earn a yellow and blue ticket on the same day? Let's list the multiples first. So, we take a look at the multiples of 9. We can go 9, 18, 27, 36, 45. We'll stop there. Let's take a look at the multiples of 15. We have 15, 30, 45. Well, there we go. They have 45 in common. The least common multiple equals 45, which means that in 45 days, you'll be able to earn a yellow and a blue probability ticket on the same day. The other way that you can do it is using prime factorization. So we'll take a look at the 9. I'm just going to use the space above up here. And I can factor that out. 3 times 3. And then I have the number 15. I can factor that out. 3 times 5. All right. So let's see what I have. So I have 9. Oops, sorry. I didn't want to do that. I've got 3 times 3. Well, that would be 9. So I guess I did want to do that. And then 15 would be 3 times 5. I can only use these once. This is what they have in common, the 2 3s. So I'm going to use that once when I multiply. So now I'm going to multiply 3 times this 3 times this 5. And 3 times 3 is 9. And 9 times 5 is 45. So every 45 days you can earn a yellow and a blue probability ticket on the same day. And that's using the least common multiple to help you solve that problem. The last problem. On your practice, or the reteach 9.4, the numbers they give you are 20 and 30. So again, I turn this into a word problem, so this will help you understand why it's important to learn how to find the least common multiple. So here's our problem. Oliver's pet mouse and Thane's pet mouse will be running a race. The boys created an obstacle course for their rodents, hopefully not in school. Both mice began at the same time. Oliver's mouse ran the course once in 20 seconds, and Thane's ran the course in 30 seconds. If they keep running at the same pace, how long will it be before both mice are side by side again, just like they were at the beginning? So I can write it this way. We have 20 seconds for Oliver's mouse. So let's write those in multiples. 20, 40, 60, 80. And let's take a look at Thane's. His ran once around the track every 30 seconds. So we have 30, 60, 90. Oh, well, look at this. We have the 60 in common. So if they keep running at the same pace, how long will it be before both mice are side by side? Well, they'll be side by side in 60 seconds, which is the least common multiple. The second way of solving this problem, and I'm going to write this in the space above so I have a little more room, I'm going to use prime factorization. So 20, I'm going to choose to do 4 times 5. That's 2 times 2. I'm going to bring down the 5 so I don't forget about it. So 2 times 5. And the number 30, if I use prime factorization, I'm going to use, let's say, 5 times 6. And 6, I can multiply 2 times 3. Bring down that 5 so I don't forget about it. So now what am I going to do with this? Well, with the number 20, I've got 2 times 2 times 5. With the number 30, I have 5 times 2 times 3. They have a 2 in common, so I can only use that once, so I might as well use that one first. So we're running out of space. 2 times, I think I'll use this too, 2 times, oh, they have a 5 in common too, just notice that. So I'll use the 5 once, so there's the 5, and then I'll use that 3 times 3. So 2 times 2 is 4. 4 times this 5 is 20, and then 20 times this 3 is 60. So again, in 60 seconds, they will be running side by side once again. So the second way using prime factorization should always turn out the same way as listing the multiples. You can always use that to check yourself. Hopefully this helps you in solving word problems.